In this video, we're going to focus on the law of sines. So let's say if you have this triangle, let's say this is angle A, angle B, and angle C. Across angle A, you have side A. Across angle angle B, that's side B, and across angle C, side C. Now the law of sines, it states that a sine of angle A divided by side A is equal to sine of angle B divided by side B, and that's equal to sine of angle C divided by side C. So that's the equation for the law of sines. But we're going to work on a few examples and how to use that equation. So let's say if angle A is 45 degrees and angle C is 59 degrees and side C is 52. So what we want to do is solve for all missing parts, all the other angle and the missing two sides. So angle A, that's 45 degrees. And angle C is 59. Side C is 52. So this is the condition where we have, this is the SSA condition. What we have is a side, an angle, and an angle, SSA. The first thing I would do is find the missing angle. The three angles have to add up to 180, so angle B is 180 minus 45 minus 59. And that is equal to 76 degrees. So that's angle B. And then you could find the missing sides. So let's find side A. So sine of angle A, which is 45, divided by side A, is equal to sine of angle C, 59, divided by side C, which is 52. So to solve for side A, what we need to do is we got to cross multiply. So 52 sine 45 is equal to A sine of 59 degrees. So dividing both sides by sine 59, we can get the value of A. So just make sure your calculator is in degree mode, because if it's in radian mode, you won't get the right answer. 52 sine 45 divided by sine 59. The answer that I got for that is about 42.9 for side A. So now we need to solve for side B. So let's use C and B. Sine of angle C, which is 59, divided by side C, which is 52. That's equal to sine of angle B, which is 76, divided by sine or side B. So once again, we're going to cross multiply. So first we have B sine 59 is equal to 52 sine 76. So let's divide both sides by sine 59. So 52 sine 76 divided by sine 59. Side B has a value of 58.9. So that's the first case where we have two angles and a side. So side, angle, angle. Now let's look at the second scenario. ASA. So we're going to have an angle, 51 degrees, another angle, 34, and a side, which is 73. Now it sounds similar to the last problem we had because we had two angles and a side. But this one's a little bit different. So this is angle A, angle B, angle C. So angle A is 51 degrees, angle C is 34, and we have side B, which is 73. So if you analyze it from left to right, we have an angle, side, angle. So this is the ASA, angle side angle, condition rather than SAA, which was side angle angle. So let's find the missing angle first. So angle B is equal to 180 minus 51 minus 34. Yeah, if you have two angles, just go ahead and find the third one. So angle B is 95 degrees. So now let's solve for side C. So sine of angle C, which is 34, divided by C, is equal to, let's use B, sine of angle B, which is 73. Actually, well, no, not 73, 95. Sine 95 over 73. Yeah, this is side B. So let's cross multiply. So 73 sine 34 is equal to C times sine 95. So 73 sine 34, if we take that and divide it by sine 95, we get the value for C. So C is about 40.98, which if you want to, you can round to 41. So now let's solve for side A. Let's use B and A because for C we have a rounded answer. Sine of angle A, which is 51, divided by sine A is equal to sine of angle B, that's 95, divided by B, which is 73. So once again, let's cross multiply. So A sine 95 is equal to 73 sine 51. So take 73 sine 51 and then divide that by sine 95. So side A is 56.95, or if you want to round it, it's about 57. So that's how you solve the angle side angle triangle using law of sines. It's very similar to the first example. Now for our third example, we're gonna solve the SSA triangle. So let's say if angle A is 44, side A is 80, and side B is 63. So here's angle A, B, C. So angle A is 44 degrees. And side A, that's 80. Side B is 63. So we need to find side C as well. So for this situation, what we have here is we have a side, and then an angle. So this is side angle. And for this situation, you only get one solution. Pretty much like the other ones, we got one solution as well. So let's start by solving for angle B. So sine of angle B divided by B, which is 63, is equal to sine of angle A, which is 44, divided by A, which is 80. So if we cross multiply, 80 sine B is equal to 63 sine 44. So if we divide both sides by 80, 63 sine 44 divided by 80, as a decimal I got 0.547. So now what you want to do is take the inverse sine of 0.547. If you do that, you're going to get angle B. and that's about 33.16 degrees, which we're just going to say 33 degrees for B. Now, if you want to find angle C, it's 180 minus 44 minus 33, which is 103. By the way, whenever you take the inverse sine to solve for an angle, you need to realize that you can get two possible answers. This is the first answer. The other answer is 180 minus 33.16. which is 146.84. However, this angle is too big because angle A and 146.84 exceeds 180. And so when that happens, we only get one solution rather than the two possible solutions. So anytime you use inverse sine, just keep in mind you could get up to two answers. You just have to check your second answer and make sure that the previous angle that was there doesn't exceed 180 with this new angle. By the way, when you get to this point, what you need to do is take the inverse sine of both sides. Inverse sine of sine B, those two cancel, you just get B. And on this side, you just get inverse sine of 0.547, and that's what we get. So that's how you go from this step to this step. Just take the inverse sine of both sides. So now to finish this problem, we need to solve for side C. So sine A, sine 44, divided by A, which is 80, is equal to sine of angle C, 103, divided by C. So 80 sine 103 is equal to C times sine 44. So 80 sine 103 divided by sine 44 will give us the value of C, which is 112. Notice that the largest side is across the largest angle. The smallest side is across the smallest angle. So as the angle increases, the side will increase. So that's something that it's useful to know for triangles. So let's try our next problem. So let's say if angle A is 41 degrees, side A is 53, and side B is 63. Let's draw the picture first. So angle A is 41, and side A is 53, and side B is 63. How would you describe this triangle? Would you say it's side, angle, side, angle, side, angle? How would you describe it? So this is a side. Next, there's a side, and there's an angle. So it's called side, side, angle. And there's two solutions for this particular example. But we'll see. We'll know for sure when we solve it. So let's start by solving for angle B. So sine of angle B divided by B is equal to sine of angle A divided by A. So let's cross multiply. 53 sine of B is equal to this. And let's divide both sides by 53. So 63 times sine 41 divided by 53. This gives us a decimal value of 0.7798. So now what we're going to do is we're going to take the inverse sine of both sides. So these two will cancel, and then B is equal to the inverse sine of 0.7798. And so the angle that we get is 51.2 degrees. Now there's another possible triangle too. And so it's 180 minus 51.2. And that's about 128.8. So I'm going to save that answer. I'm just going to write it down. So what we're going to do is we're going to solve two triangles. This is going to be the first one, where B is 51.2. And then we'll solve the second triangle as well. So let's find angle C. So angle C is 44. Well, it's 180 minus 41 minus 51.2. So angle C is equal to 87.8 degrees. So now we could find side C. So sine of 87.8 divided by C is equal to sine A. That's a 41 over 53. So side C is going to be 53 times sine 87.8, and then divide that by sine 41. So when you solve it, you should get 80.73. Now I'm just going to take a minute to write down what I have, because I'm going to clear away the page. So now we're going to solve the second triangle. So angle A was 41 degrees. And the new angle for angle B is 128.8. Side A was 53 to begin with, and side B was 63. So let's find a new angle for C. So it's 180 minus 41 minus 128.8. And so you get 10.2. So now we can find we need to find side C. So sine of 10.2 divided by C is equal to sine 41 over 53. So side C is about 14.3. So that's the second triangle. I'm going to redraw the first one that we have. So these are the two solutions for this particular case. And in each situation, you can see that the largest angle is across the largest side. And in this situation, C is the largest angle, and side C is the longest side. And it always seems to work out that way. Here in this case, angle C is the smallest angle, and side C is the smallest. So that's how you can use law of sines to get two answers. Whenever you use the inverse sine function, just don't forget to subtract the first answer by or from 180 to get the second possible angle. So what about another situation where there's no solution? So let's say if angle A is 74 degrees and side A is 49 and side B is 69. So let's draw a picture. So this is angle A, B, and C. So here is 74 degrees. Side A is 49. And side B is 69. So we still have a side-side angle triangle. So let's solve for angle B. So sine of B divided by B, which is 69, is equal to sine of angle A divided by A. So if we cross multiply, what I'm going to do this time, I'm going to solve it a little differently. I'm just going to multiply both sides by 69. I think it's easier that way. The thought just came to my mind. So here the 69s will cancel, and we already have sine B. So sine B is 69 sine 74 divided by 49. So let's get the decimal value for that answer. So sine B is equal to 1.354. Now here's what you need to know. The sine function varies between 1 and -1. If it's outside of this range, there's no solution, which in this case is going to be no solution. Let's say if you take the inverse sine of both sides. These functions will cancel. If you try to type this in your calculator, inverse sine of 1.354, your calculator will give you some sort of error message. My calculator says math error. So this can't be done. So therefore, there's no solution. This triangle can't be, you can't solve it. Now the next thing we're going to talk about is how to find the area of an oblique triangle. Because usually with this topic, if you have a test on law of sines and law of cosines, chances are you need to be able to find the area. So let's say if this side is 12 and this side is 15 and the angle between them, let's say it's 45 degrees. So here we have a side angle side. So we have a side angle side triangle, SAS. The equation that you want to use is area is equal to 1/2 AB sine of C. So let's say this is angle A, and if this is angle B, and this is angle C. Angle C, therefore, is 45 degrees. This would be side A, this is side B. So if you have the angle and the two adjacent sides, you can use this equation. So it's 1/2 15 times 12 sine of 45. Half of 12 is 6, and 6 times 15, that's 90. And sine 45, that's root 2 over 2. So 90 divided by this 2 on the bottom, that's equal to 45. So the answer is 45 root 2. That's the exact answer, but if you want the decimal value, the area of this triangle is about 63.64. So that's how you can find the area of an oblique triangle. But now let's say if you have a triangle and let's say if you know that this is 10, this is 11, this is 12. So we have the value of A, the value of side B, and the value of side C. So this is side, side, side. Let's find the area of the triangle. You need to use Heron's formula. So first you need to solve for S, which is A plus B plus C divided by 2. So A is 10, B is 12, and C is 11. So you get 33 over 2, which is about 16.5. Now after you find S, you can now find the area. which is the square root of s times s minus a, s minus b, and s minus c. So s is 16.5. And then 16.5 minus a, which is 10. And then 16.5 minus b, which is 12. And then 16.5 minus c, which is 11. And then you could just type that in exactly the way you see it in your calculator. Just don't mistype any numbers. So the area that I got is 51.52 for this example. But now let's say if we want to use law of cosines. We can't really use law of sines because you need at least one angle to solve the triangle with law of sines. So we have to use law of cosines if you want to solve it. To find one of the angles, well, the original equation is c squared is equal to a squared plus b squared minus 2, I forgot the 2, so minus 2ab cosine c. That's if you want to find like side c or something. But we have all three sides. If you want to find the angle, it's c squared minus a squared minus b squared divided by negative 2ab, which equals cosine of angle c. Once you find the first angle, you can use law of sines to find the rest. So let's solve this example. So c is 11, a is 10, and b is 12. Now what I would do is just get the decimal value of that fraction. If I typed in everything correctly, I got 0.5125, and that's equal to cosine of c. So therefore, c is equal to the inverse cosine of that number. So inverse cosine of 0.5125, angle c is therefore about 59.2 degrees. So now, once you have one of the angles, you can use law of sines to finish it. So let's solve for angle A. Sine of A divided by side A, which is 10, is equal to sine of C, or 59.2, divided by C. So I'm going to multiply 10 by both sides. So these two cancel. So therefore, sine of A is equal to 10 sine 59.2 divided by 11. So that's 0.7809. So A is equal to the inverse sine of that decimal value. And so angle A is 51.3. Now, find the other answer, 180 minus 51.3. The other possible angle is 128.7. But 59.2 plus 128.7 exceeds 180. So we don't get two solutions, we only have one. So now that we have angle A, we could find angle B by subtracting 51.3 and 59.2 from 180. So angle B is 69.5. So that's how you can solve the triangle if you have all three sides. Start with find the first angle, or angle C, using law of cosines, and then use law of sines to solve for everything else. Here's the last scenario. So let's say if this is angle A, B, and C. Let's say angle C is 40 degrees, and side B, let's say it's 9, and side A, we're going to say it's 10. So notice that we have all three different letters. We have angle C, which is 40, side A, and side B. Usually, when you have one angle and two sides and all letters are different, you can't use law of sines. You have to use law of cosines. Because, I mean, let's say if you use sine of angle 40, you don't have side C. Side C, we don't know what it is. And we can't use angle A or B because we don't know what they are, so we have to use law of cosines. But we're going to solve for side C first. C squared is equal to A squared plus B squared minus 2AB cosine of C. We're going to use this form of law of cosines. So A is 10, B is 9, and cosine of 40. So you could just type that in. So 10 squared plus 9 squared minus 2 times 10 times 9 cosine 40. We should get on the right side, I got 43.112. And that's equal to C squared. So then if you take the square root of both sides, C is equal to 6.57, which I was going to round it, but I'll leave it at 6.57. So now let's solve for angle B. Now we can use law of sines. So sine of angle B divided by 9 is equal to sine of 40 divided by 6.57. So let's multiply both sides by 9. So sine of angle B is therefore equal to 0.8805. So B is equal to the inverse sine of that answer. So angle B is 61.71. Now let's see if there's two solutions. So 180 minus 61.71, that's 118.3. Now 40 and 118.3 they don't exceed 180, so we do have two possible triangles. So I'm going to solve this one, and then I'll solve the next one let's finish this one first. So to find angle A, it's 180 minus 61.71 minus 40. So angle A is 78.29, or 3 degrees. Okay, so now let's solve the second triangle. So let's say that C was already there, so this is 40. A is 10, B is 9, this is 118.3, and the missing side. So it appears as if we have two solutions, but does it work? That's the real question. Notice that even though we do have a second angle where these two angles is less than 180, this second solution doesn't work out very well. Because angle B is not across the longest side. So that can't work. What we have to do to finish it is we may have to find a new value for A. Because law of sines, it works for 40 degrees, 6.57, 118, and 9, because we got angle B based on B and C. So we have to re-evaluate our answer for A, because if the angle is 21.7, this side can't be the longest side. So let's fix that answer. So sine of 40 over 6.57, which is equal to sine of 118 over 9. but we're going to set that equal to sine of angle A, which is 21.7, divided by side A, which we're going to resolve it. So 6.57 sine 21.7 divided by sine 40. So A, the value for this triangle should be 3.78. And notice that this side is the smallest side because it corresponds to the smallest angle. B now is the largest side, which corresponds to the largest angle. And now everything works. So we have to change our value for A for this particular situation. So that is it for law of sines and law of cosines. Now you know how to use it. You know how to find the area of oblique triangles, or if you're given three sides to a triangle, you know how to solve that situation as well. So thanks for watching this video.